Okay, so we'll look at this parallel workers or parallel taps kind of questions. So you have a question in which, let's say you have three people who are working. Right? So let's say this person has some machine tools, this person has hand tools, this one is using whatever is around with him. So they take different amounts of time to do some work. Okay? Something like that, right? So whether it's painting a wall or whether it's digging a well or something like that, right? So you say, okay, this person takes 10 days to do this work. This person does 8 days to do this work. And this person takes 20 days to do this work, whatever. And then you are expected to find out if all three of them worked together in parallel, assuming they are not fighting, killing each other and so on, that they'll actually get the work done faster. How much time will it take to get the work done? So most of the times we solve it by saying, okay, the unit, let's say the work is a unit work. So how much work will get done in one day is 1/10. How much work will get done by this person is 1/8. How much work will get done by this person is 1/20. Then you take the LCM, of course you add them together, then you flip them around and so on. But some children have difficulty with fractions and addition, it gets confusing. So the question is, the choice of how much work was there was up to us. We chose to say it's unit work. It doesn't have to be unit work. And one of the ways of doing this whole question is to look at it as, okay, let's fix a amount of work up to us which is convenient. And what is convenient is the LCM of the numbers. So if three numbers are given, anyway you take LCM of a fraction, I get it. But anyway, let's say you take LCM of your 10, your 8 and your 20, right? So you take 2, it becomes 5, this becomes 4, and this becomes, 10. And then you can take one more 2, right? So that 5 stays as it is, this becomes 2, and this becomes, oh sorry, what did I do? Yeah, this becomes 5, right? And then you take 5 because that's also common. So that becomes 1, this becomes 2, this becomes 5, and 1. And then we are done. These are the only common factors we have. So this is 2 times 2, that's 4, 4 times 5 times 2, which is 40, right? This is 10, together this is 10, so that's 40. So I know the LCM is 40. So I can say that I can assume my total work was 40 units. Okay, which I'll use again when I want to divide in the end. So my total work, which we used to always define as 1, is 40 units. Then the first person, his efficiency, how much units he does in a day. So number 1, maybe I should have used different colors. Okay, we can. Let's say I'll use green for the first guy. Is how much work is there? So this is first person, 40 units divided by 10 days. So this is basically 4 units per day. Okay, so that's what the first one does, right? So then let's say the second one. Alright, fine. We'll color him a little bit here. And his 8 also has a bit of a color. Okay, so that's 8. Alright. So this is second person. So second person, and this is efficiency, how much work he does in a day. So second person, so this is called the efficiency mode. The whole thing. So second person's efficiency is the same 40 units divided by 8. Now remember, because it's LCM, you'll always be able to divide. Okay, so this is basically 5 units per day, right? And so then we have a third person. This third person is rather colorful. He's very busy doing many other things. That's why he takes 20 days. So, third person, same 40 units of work, same divided by 20 days. This person gets 2 units of work done per day. Certainly seems part-time, right? Okay, so there you go. So this is what you have. And then if you want to know how all three of them perform together, then you simply say together they will get 4. Oh sorry, I should have used the colors. 4 plus 5 right, plus 2 units of work per day, right? That's together their efficiency. And so that is 9 plus 1, 11. So 11 units per day they get done together. Okay. So then you just say, okay, what is the total number of work? Total work divided by the combined efficiency is the number of days they take. Total work divided by efficiency. So total work is 40, which is units, divided by 11 units per day. Day goes up, number of days is 40 by 11. That's it. So this is a approach in which you are still doing the principles, you are still doing LCM, where you are using that to define total work, but then you are not doing any fraction addition and some of that. You are just getting it into numbers, adding the numbers and taking a ratio, which many people find more comfortable and convenient. So that's how you do parallel workers or parallel taps that are filling a jug of water or a can, that kind of things.